Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 4 of the lesson on integration by substitution, and in this video I'll be taking you through one more example that has trig identities all over the place. So here we go. We're being asked to find the value of the integral of sine 2 theta root 1 minus cos theta with respect to theta between the limits of 0 and pi over 2. And the substitution we're going to do to achieve this is u squared equals 1 minus cos theta. So something looking different straight away. We've got u squared equals. We've not seen one like that before. We'll talk about how to deal with that as we work through the substitution. The first thing that I always encourage students to do with integration by substitution is to change the limits, because it's something that you're likely to forget later on after you've done all the work of changing the integral itself. So let's have a look at that first of all. Now these two limits here, 0 and pi over 2, because we're integrating with respect to theta, then they are theta limits, they are values of theta. So when we come to change our limits, we're going to be using those values in place of theta here. So the first one, the upper limit, when theta equals pi over 2, we're going to be saying that u squared equals 1 minus cos of pi over 2. Cos of pi over 2 is 0. So u squared equals 1, that's going to mean that u equals 1. Similarly, with our other limit, if theta equals 0, u squared is going to be 1 minus cos of 0. Cos of 0 is 1. 1 minus 1 is 0. So square root that, we're going to have u equals 0. So they are going to be our new limits that we're going to evaluate between. Now the other thing that we need to consider with this is what we're going to do about this d theta, so that we get it in terms of u, because that's what we're going to be using as our substitution. So if u squared equals 1 minus cos theta, then u would equal 1 minus cos theta to the power of a half, or square root of 1 minus cos theta, which you'll notice is quite nice. That's going to go in there. But we just need to think about how we're going to differentiate this and get to a point where we can swap out d theta. So how do you differentiate this in terms of theta then? Well, we've got something in a bracket with a power, chain rule. So du d theta is going to be 1/2 1 minus cos theta to the power of negative a half multiplied by the differentiated bracket. Now we've got 1 minus cos theta, so negative cos is going to differentiate to positive sine, so multiplied by sine theta. Now it's very, very important that we can write that in fraction form, because here where we're having to swap d theta, we're going to have to take the reciprocal of this expression. So let's just take the time to do that properly. Du d theta is going to equal, now what's going to be on the numerator? The 1 and the sine theta. And that's going to be over 1 minus cos theta to the power of a half. So I'm going to write that as the root of 1 minus cos theta, like that. The reason for doing that is we're going to now take the reciprocal to say that d theta du is equal to the root of 1 minus cos theta over sine theta, which means that d theta is equal to the root of 1 minus cos theta over sine theta du. And what I'm now going to do is replace d theta in the substitution with this and see what we end up with. So I'm actually just going to rewrite the original integral, which was sine 2 theta between 0 and pi over 2, root 1 minus cos theta d theta, and think about what's swapping. Now this is going to go in for d theta, so I'm going to do that bit first and look to see if anything can cancel. So we've got the integral of sine 2 theta root 1 minus cos theta, and then instead of d theta I've got multiplied by root 1 minus cos theta over sine theta du. Okay, so it's going to eventually be with respect to u. Now, a couple of things we can see. We've got root 1 minus cos theta multiplied by root 1 minus cos theta. So that's going to become 1 minus cos theta. So I'm going to write that in my next stage. 1 minus cos theta, which is those two things multiplied together. And I'm now going to write multiplied by 1 over sine theta for this second part here, du. Now we should be looking at things cancelling, and I've said to you about trig identities. What trig identity are you seeing there for sine 2 theta? Hopefully what you're seeing is 2 sine theta cos theta. So that is sine 2 theta swapped to the identity 2 sine theta cos theta. And this is what we're integrating. Now why do that? Well, the reason that we want to do that is because we can we can cancel that sine theta with that sine theta, which means that what we're actually going to be integrating is 2 cos theta (1 minus cos theta) with respect to u. Now let's consider what our substitution was. U squared equals 1 minus cos theta. So that's quite nice. That's going to go straight in there as u squared. And now I've got 2 cos theta. So if I rearrange this to be cos theta equals 1 minus u squared, I can now rewrite my integral as 2 lots of 1 minus u squared, and then 1 minus cos theta is just u squared with respect to u. Now at this point I need to think about my limits because I want to be using my u limits now. So I'm going to go back to the very first thing that I did, which was finding the new limits were 0 and 1. So let's put that in down here. 0 and 1. Okay. This is going to expand out to be a polynomial integration. So 2u squared multiplied by 1 is going to be 2u squared. And 2u squared multiplied by u squared is going to be u to the 4, so 2u to the 4. And we're going to be integrating that with respect to u between the limits of 0 and 1. So I can integrate that polynomially as normal, and it's going to fall out quite nicely. So I'm going to get 2/3 of u cubed minus 2/5 of u to the 5 between 1 and 0. Don't need the plus c because it's definite integration. So substituting in the 1, substituting in the 0, that's going to give me 2/3 minus 2/5 minus 0, which falls out rather nicely as 4 over 15. So that is the value of that integral, 4 over 15. So let's just have a quick review and look at what we did. First thing we did was we said let's change the limits so we don't forget. We then looked at how we were going to deal with this d theta, and we talked about how you had to write u equals, differentiate, and it was important that we were able to write the result as a fraction so that we could take the reciprocal. We then didn't dive in with the swap for u squared straight away. We looked at what was going to happen when we substituted in d theta, and we found some things would simplify, some things would cancel because we knew that trig identity. And then what we ended up integrating was something that was actually quite nice. And we got 4 over 15, quite a pleasing result. So there we go. I'm so chuffed that we've done that, I'll throw my pen on the floor. That's the end of the lesson on integration by substitution. Thanks for your company. I'll see you again.